Hey everyone, your favorite binary wacky reality creator is back at you again with some more Dark Souls 1 Omnification. An Omnified game requires, at the minimum, 3 of my special systems to be implemented into the game. The Apocalypse system, the Predator system, and finally, the Abomnification system. And that's what we're going to be doing today. Once that's done, the game is omnified to stream. What's the Abomnified system? As soon as I have it available, I will be linking a general overview video that will tell you all about it. Until that happens though, I'll summarize. The Abomnification system applies randomly determined different morphing modes of varying speeds to all non-player characters in a game. This makes them constantly change shape in a manner that is very reminiscent to taking high doses of acid. It's fucking awesome. Implementing the Abomnification system can be a toughie, because that requires you to be able to manipulate the scale of creatures in the game. Some game engines make this super easy to do. It's very common to have the creature scale represented as 3 separate numbers for height, width, and depth, typically floating point values, right alongside the coordinates. But some games don't have such a scale implemented in their game. You see this especially with games that have custom engines. FromSoft games fall into this category. You have to go extra deep to be able to manipulate the dimensions of character models. In fact, we have to create our own scaling functionality. The first time I successfully did such a thing was in my Omnified Sekiro, and we're gonna do it again for Dark Souls 1. Luckily for you, and luckily for me, I documented the process I used to find the area of code that lets us screw with the size of the characters. This is way beyond your standard cheat engine change scale tutorial. This is next level, and I'm very happy to be able to share how I did it with y'all. Let's go. All right, everybody. To start things off with, let's go over how I discovered where the code is that we're gonna be hooking into. This code allows me to change the shape and sizes of creatures in the game. When I did the Abomnification video for Sekiro, I actually didn't include this process with the video, mainly because it took me a while and I didn't keep notes. This time I kept notes, but also it only took me around 30 minutes to find. I'll have to credit, I guess, experience and all that, and probably a little bit of luck. So this game doesn't have any built-in scaling capability like you see with so many other games. There's no available floating point value that I can change, at least I am 99.9% sure of this, that I can change that will cause my character to change their shape. And specifically, there's not one in the common areas you would expect to find it, like next to the coordinates. Old Omni would have given up if there was no scaling parameter, but new Omni has a brand he has to uphold, and Omnified games need to have Abomnification. Therefore, if I want to play a game, we got to figure out how to change the scale. My own expectations of myself can be quite oppressive, but as they say, oppression is the mother of innovation. All right, so here's how I did it. First of all, I figured that I would need to figure out my character's height. You know, what is the character's height? So what I did is I put my character on some stairs, like down here, and I moved my character until my head was level with the floor, right adjacent to it, right here. So you can see it's not exactly an exact science, but try to get it lined up as perfectly as we can. And then I recorded my current coordinates down here. And then I moved my character so he would be standing right on top of where his head was. I'll get there, don't worry. Let's say that was right here, exact. Then I would record my new coordinates. Then I would take the difference between the Y coordinate, which is just gonna basically determine, you know, where I am vertically. Here, the difference between this and the Y coordinate from when I was standing on the stairs, that basically gives us our height. I think my height was like 1.3 or something, I don't remember. And then in Cheat Engine, I did a search for floats in the game, and I probably just removed a few decimal places from my calculated difference of the Y coordinates. And then that would give you, hundreds of thousands or millions of results, of course. And then I had to figure out a way to be able to change the height, so I could search for changes that were decreasing and then increasing. So unfortunately in this game you can't crouch. In a normal game I would crouch. So I was just playing around a little bit, and I noticed that my height would go down when I did like a strong attack. Like that. You can see my head dips a bit. I also think it goes down if I just do a normal attack. Yeah, right after the attack's done, your head's down for a bit. My height is essentially lower there. even though, you know, I'm bent over, my character, if he stood up, would be the same height. That doesn't matter. What matters is my height is actually smaller. So what I did is I wired up some hotkeys to the some of these various next scan options. I wired up a hotkey for increased value and one for decreased value. Can't pause in Dark Souls, so I had to do this basically. I set it to something very simple like 0 and 9 or whatever. And what I would do is then in the game, I'd you know, swing my sword. And right when I ducked down, I'd hit the hotkey to look for decreased values. And then when my character stood back up, search for increased values. And we kept on doing that for a while until we got down to about 1,500 values I think I had, which is a lot of values, right? So then I decided, hey, let's look for the values that are in a region of memory that are most likely to apply to my character. And what I did is, in a previous video, we created a code that creates a pointer that points to our character's coordinates. And you know, those coordinates are stored in memory somewhere. So I thought, let's restrict the range of memory that we're gonna be looking at to a range that's around that place in memory where my coordinates are. Because I've seen in many games, I've seen in Sekiro 2, there's definitely a modeling data around the physics module, as it was referred to in Sekiro. I don't know if it has that formal name in this game. And so that gave me, you know, a few to look at, and I then would go into the code that was writing to these places in memory. And I was brought to this code right here. And what I would do to see if it was something that I cared about is we would replace the code with nothing. And so if this is code that I could use to fuck with the scale of the character, if I remove this here and I do my attacks as I was doing before, my height should not change anymore. So let's see if my height changes. As you can see now, I no longer duck down. Looks kind of, sorry, this is just hilarious to look at. We don't duck down anymore, which means this code is basically controlling our height. What gets written to this code right here, or this place in memory, that determines my height essentially. Now, this is gonna be written to a lot, and it's not gonna be one address in memory per character. I'm quite confident that there's not tons, but there's many of these addresses that get written to per character. And this is most likely in some sort of loop. So with the code back in there, as you can see, now I duck down. So that's where we're gonna be putting our scaling code. And indeed, this is for the height here. And then you can tell because these are separated by 10 or 16 bytes, that this is like a full row, SSC register row, or 4 double words, 4 floating points worth of data. And I've observed with Sekiro and all that typically each dimension that we're gonna care about is gonna be made up of a row of these floating points. And so we can assume then that if this is the height, that this is either the width or depth up here, which is 10 removed, and then this is either the width or depth down here, which is also 10 removed from that. So we can think of these as like, this is height, this is width, I believe, and this is depth. Fortunately, and it's somewhat annoying, because of how this code is structured here, we have to have 3 separate hooks here. I like to be as least invasive to the original code as possible, and I can't just put a hook up here, unfortunately, because this value gets read here. Though I suppose I could just up here write to this, like, I guess, intermediary struct, and then it would get read and propagated down here. So that's also very possible. But why should you believe me? Maybe I don't know what I'm talking about. No, I know what I'm talking about because I can make my character fat. Behold, as I check this box here, I get fat. Look at that. Look at this sexy boy there. Nice and wide. Technically he's not fat, he's just wide. So that's not fair, is it? So there you go. I don't think anyone's actually been able to manipulate scale that well in this game. And one thing I know for sure that people have not been able to do, and when I do these hacks, I don't look at anything online, any existing hacks or anything usually, mainly to force myself to learn and you know, be able to provide to you guys how I do stuff, since we can all learn then. But when I was doing the Sekiro scaling changes for the Abomnification system and that, it was a very difficult thing to do, and so I was a little desperate. So I did Google Sekiro scale change hack, and there's just nothing. And like really, no one's done anything for these games, if I'm not mistaken, except for I think I read somewhere one of the Dark Souls, there was a table where people could change the scale of every single creature in the game. It was like a global model scale modifier. So let me show you then something that has not been seen before. That one did make me big, but I am actually able to filter out the player from the scaling changes we're doing here, and I can selectively apply it. Observe the zombie over there. I'm gonna make him tall and not me. Look at that. He changed, but I didn't. So there you go. We'll be going over how I did that in the video while we're actually implementing the Abomnification system. So now that we got that scale stuff figured out, what do we need to do in order to get this Abomnification system in there? Well, other than the whole scale thing we talked about, typically the scale things are taken care of for us in the game through the availability of a scaling floating point baked into the game's engine. So that's going to be another part that we have to do. The first part that we normally have to do is we need to generate the random morphs and generate the random numbers that are set as morphing targets that the various characters are going to be morphing to, etc., etc., etc. Essentially, we need to throw in my system code into it. So what does that require? Well, with most of my systems, it requires us to find the correct place to hook into. Although, for the Abomnification system, the initiation point, the place where we actually initiate it, it's not as specific as the other systems. Basically, anywhere where coordinates are being pulled as a big plus, somewhere that is only pulling for creature coordinates. If I can find a place like that, that's perfect. That's where we're gonna put it in. But other than that though, one special thing we need to do for the Abomnification system is we need to find some chunks or regions of memory where we can store per NPC data to. So that means I have to go through the structs in the game, the data structures, and see if there's anywhere that I can store this data will be generated inside the morph scaling functions that are specific to a particular NPC. I think for Sekiro, where I stored it was inside the physics module for each character. The physics module is the data struct that held coordinates. I don't know if coordinates even have their own module in Dark Souls, but one place we can, we'll first try to store this stuff is inside the player/enemy instance data structs, which are kind of like the root of all their data. So let's take a look right now. So let's bring up enemy instance data struct right now. This right here, my health, the pointer it's an offset from is actually my player instance struct. I still need to rename this to be player instead of player health. But let's take a look and see what is going to access this address here, and maybe we can find something accessing enemies' addresses. All right, so we had all these functions pop up here that are reading this. I went down a little bit here until we got to this one, and this one was accessing a whole bunch of different addresses, more than just me. And as we can see here, there's a number of different creatures it's reading from. So that makes sense. There's about this many enemies in the area, I think. And then we took one of the addresses here, and let's copy the address to the clipboard. And I'm going to open up a dissect structure window for it. So the offset it's accessing the health with is 3E8, so we want to subtract 3E8 from this, so we get the base of it. And just to verify that this is actually an enemy instance structure, is to, I guess, new structure, and it tells you it's an enemy instance, good. So let's find some region of memory here that looks like it might be safe to write to. I typically look for places that are a lot of zeros in them, white space zeros, but not too many. It's impossible to know for sure if it's going to be safe or not for any extended period of time. You just have to try out a region and then hope it sticks. But if it isn't going to stick, it usually doesn't take too long to stops working. Look, I scroll down a bit and I notice there's a big region of memory right here. A big chunk right here. Maybe we can use that. I need about, I guess, 14 4-byte allocations of memory. So 14 of these guys here. So there's a big chunk right here. This is easily 14. Let's start right here. And let's just designate these struct members as the Abomnification parameters, and then we'll use that in a reference during our implementation of Abomnification System. Now, I did something very stupid. I labeled all these different areas without doing any kind of safety checking. What I should be doing is I should set all these fields to a number and see if they stick. Let's see if they get reset right away or zeroed right away. And then also, I should, experience has taught me this, I should leave the area, quit the game even, and see if it crashes the game. So let's set all these values here and see if anything bad happens. And as you can see right here, I set a value to it and it immediately goes to 0. So I just wasted a lot of time. So let's try to remember the order in which to do things properly next time. And then we're gonna move all this stuff to that area. Now let's see, and so this is a value that sticks. That value sticks. That value stuck. That's stuck. Let's see how many we got there. These values did stick, but where the location makes me nervous. Down here we have even more space. All these values stuck around. All right, it seems like we can store stuff here, but first let's kill our character and see if, by having these bytes set, if the game crashes. It's definitely a possibility. Good, game didn't crash. Well, I wouldn't call that an incredibly exhaustive test there, but I am more confident than I am normally with using these as the actual places. So I'm gonna move all those places I defined before and I'm gonna put them down here. I'm gonna use those in our code. Ready? All right, so here is the updated location of all our Abomnification System memory parameters in the new area in the enemy instance data struct. So we're gonna leave that open, and now we're gonna be implementing the code actually. So unlike my other systems, I still have to formally game neutralize this one. When something's game neutral, it means I can copy this big function into some assembly I'm gonna inject, and I can call that function like you would call a normal function, and it will work just great. You don't have to change anything inside that function, etc. It should work no matter what game. And I still need to do that with the Abomnification. But it basically is going to be just a copy-paste job anyway. I'll probably just do that when I make the Abomnification general overview video. What we have to do to implement the morphing scaling portion of the Abomnification system is I'm going to hook into the area code where we got the enemy instance data struct, and I put the Abomnification system code there, and I just have to replace all the memory addresses with these right here. So there's gonna be an address used for the X scale, and make sure it reads 9B8 and this one 9BC for the Y scale, etc. So we're gonna hook it into right here where we got the data structs from. This code basically appears to be a code that is looking at NPC health and player health in the map. I can't see every creature that is being returned here, so it seems to be map wide or so, or at least greater than is considered the visual radius. I'm gonna create a full injection in there and dress up that injection. We'll put it into our hack file. All right, we generated a hook for the area code that I went into a lot of detail about how I found. This is where we're gonna implement our own scale parameter, and it's where we're gonna load this creature's, whatever creature it's currently drawing, the Abomnified scaling parameters, and take those scaling parameters and make them into 3D magic. Basically by multiplying the contents of RAX plus 10, and then RAX plus 20, which contains, I guess, all the values for the drawing matrix by whatever that scale is for the particular row in the array. So RAX itself will be the width. So we're gonna apply the X scale there. RAX plus 10 will be the height row, and then RAX plus 20 will be depth, or Z scale. Okay, so first thing though is we only want to apply this to enemies, not the player. Although we should probably make a mode where that can happen, because that'd be funny. So we're gonna be doing some comparisons here. I wanna back up those conditional flags. How are we gonna figure out who to play and who not? Okay, I have a breakpoint stopped at here. And this is where it's drawing the 3D models for the characters. And after some poking around, I found that we can identify whether it's an enemy, whether it's the player, by looking at the stack here. We look at RSP plus 70. This is going to point to a structure known as the, I guess, control structure, either player control or enemy control. And I'm not entirely sure what this structure is responsible for. I'm going to assume something to do with movement or of the character, creature. But we can tell right then and there if it's the enemy or if it's players. If it's the player, it's going to be a structure of type player control, and enemies will be enemy control. We can see a player control example right here, and the way we identify it is by looking at the first entry in it. And this basically points to what seems to be a type information, and the last 16 bits here are 8938, and they're always 8938 if it's the player control struct. If it's the enemy control struct, it's 8588, not 8938. When we have the player control struct, then the actual player data struct is located at an offset of 10. Of course, we're going to be accessing the enemy data struct, but it should be the same offset to get to that as well. I'm doing the player versus enemy comparison here just because it's like one less level of pointer I have to go through before I can just get out of the code. So let's write the code to first see if this is a player or enemy, and then once we know it's an enemy, then we'll want to grab the enemy structure, and then we apply the scales. All right, let's determine if it's the enemy or the player. So I'm gonna back up REX and RBX. And then we're gonna look at the stack. Remember, it was at RSP plus 70. Well, we're gonna be a little bit further into the stack here because I'm backing up my conditional flags, which is 2 bytes, I think. And then we're backing up 2 more registers, so it's gonna be 16 more bytes. So this changes where we're looking from RSP plus 70 to RSP plus 82. Let's move to RBX, RSP plus 82, and it's going to contain a pointer to the control struct. And I'm just going to load the REX register with that dereferenced. And so this will be set to that type and entity member of the struct. And I'm just going to look at the lower 16 bits of it, which is going to be AX, and we're going to see if it's the player's type, which is 8938. If it equals that, if AX is 8938, then we want to get out of here because this means this is the player being drawn, not the creature. So now that we know that it's an NPC being drawn here, we want to get its instance struct. So we're going to back up our RX register again, back up the RBX register. We're going to move to, I guess to be consistent, we'll move to RBX, that control struct address. We're going to move to REX, the enemy instance struct, which I hope will be at an offset of 10 from the beginning of this struct, as we saw with the player control structure. So it's going to look like RBX plus 10 then. So this should contain the address to the enemy's instance structure. Okay, so now we have the enemy instance structure in that REX register. And so now we just apply those scales that are stored in there. It's gonna load up our defined parameters here. All right, so let's do it in the order of width, height, and depth, which is X, Y, Z, conveniently. So the X scale is gonna be, as we have here, at an offset of 9B8 from the enemy instance struct. So we're gonna load that into an SSE register. So we're gonna have to back up some SSE registers. Gonna make room on the stack for 16 bytes. I'm gonna back up, which one should we back up? I think anything works here. Back up XMM0, the first one. And then we'll restore that here. And then we're going to move into that freed up SSE register, the creature's calculated X scale, which is going to be located at REX, our enemy instance structure, plus 9B8, that's our X scale, from down here. Okay. One thing we want to do is we want to make sure that it's not 0. If it's not 0, then that means the morph scaling code is not run yet, which is very likely to happen because the code that we're injecting this into is going to be running much more frequently than any other that game data related code, which is pulling for like, are they still alive, that kind of stuff. This code here is drawing things on the screen, so it's going to be running a lot. So let's check if XMM 0 is 0. 0 is just a field I have that is floating point 0, 0. Nothing special. And if it is 0, we want to get the heck out of here, but we need to clean up the mess we've made. So let's make a. So we'll just make a exit label called that Abomnify creature exit. Otherwise, we're going to set these scales. So we got the X scale in the XMM 0 register. We actually want to broadcast into all the words vectors in the SSE register. So it'll now read, if the X scale is 2, it'll read 2, 2, 2, 2. I think those 4 2s right. And then we want to do a packed multiply. No, we don't want to do that yet. We have to load what's in that RAX register at offset 0 first. We are going to need to back up another SSE register. So let's back up XMM 1 as well. And I suppose let's load that here. Okay, so the values of the matrix it wants to draw is going to be an XMM 1 now. Now we're going to multiply that with our X scale. And then we do the same with each row or set of 16 bytes in this model matrix data structure. So now that we have what we need to multiply our X scales to loaded, let's just multiply XMM 1 or XMM 0 works, I guess, with XMM 0, which is our scaling values, and then we just have to move XMM 1 back into where our X is. And then it will now draw the creature's width or whatnot at that modified amount. Okay, as for the width, it's fairly simple here now. Now we're just going to go to the next scaling parameter, which is the Y scale. That'll be 9BC, so for Y scale. And broadcast that. I guess also we're going to load XMM 1, which holds the drawing data from RX plus 10 now. Multiply the height characteristics. Move that to RX plus 10. Now that will make the creature's height whatever we modified it to. And then let's get the depth stuff loaded. Put our Z scale in there, which is 9C0. Multiply those depth characteristics and then move it back to RAX plus 20. That's it. And once the Abomnification system is game neutralized, this is all we would have to write. And actually, we wouldn't have to write anything for games that have that easy to use scale, but I haven't Abomnified any game like that yet. Anyway, let's save this, load it, and see if it works. And if it does work, Dark Souls 1 will be officially omnified. All right, guys, just a little addendum to previous Abomnification recordings. After doing some play testing, we had to just change it up a little bit, and I took the deep plunge into managing my own memory and no longer trying to attach all this data to the enemy NPC data. Previously, we were storing all the data in 12 different data points on structs that were relationally close to the creature at hand. So basically what we were doing before is we were going up to each creature in the game and we were like, hey, man, I got like a bunch of money in 12 different denominations. Could you hold on to it for me? And they're like, whatever. And then I stuff it in 12 different pockets. Okay, but they didn't know what those pockets are for really. He just saw that they were open. Well, you know, you come to find out later that for one guy, like one pocket's for using his battle elixirs, so he would take it out, drink his battle elixir, and money would go flying out. And the other one's where he stores toilet paper, so he would take out the money by accident and wipe his ass with it. And so basically when I came around to collect my money, these NPCs would basically either not have it on them or I'd get my money back with shit covered on it. So instead we're opening up our own bank to store their money. And I just give them a single slip, an account paper that has their account number on it, and they give me that account number and I can get all their data for them. And we do it like this here. I don't know if this is the best way to do it in assembly. I see what it looks like when game code's accessing arrays of data. And we kind of do the same thing. Basically what we do here is I just allocate just a bunch of data here. I'm allocating 4,800 bytes. This is all we do with that. We just allocate this, we don't do anything else. And we have an index basically that I have. That just is a counter basically. And inside the code that contains the morph scaling code, before I do anything, this is where we interface all the parameters, I store basically their index now, their account number, in one place on their data structs. This RBX represents a data structure that can be found one removed from their instance structure, their base structure. And in this place and that, just this one little location, we store their morph scale index. And I do have a limit on the index just because, well, we can't go past our allocated data. We have 12 items of data and we have 4 bytes per item. And so 4 times 12 is 48. So each morph scale data struct, we can call it, takes up 48 bytes. And so 4,800 gives me room for 100 entries basically. So we don't want to go beyond there, else we'll be right into unallocated memory and then you blow up and you die. So that gets reset here. Otherwise we increment it and then we, oops, don't do that, and we store that index into that data struct of theirs. And then we take the index, morph scale index, and I move that into REX to be multiplied, and then I move to RCX. We're gonna multiply it by 48, right? So if you have like an index of 3, that means we're talking about the 4th morph scale entry. And so to get to that 4th morph scale entry, since each entry takes up 48 bytes, we're at the skip the first 48 bytes, and the second, and then the third, and then we're at the 4th. So that's 48 bytes times 3. So we multiply the index by the size basically here, and then we store that back in RCX to add to RDX, which is set to the base of the morph scale data. And then we can access all our data just from there, and this will all be isolated from the game. It won't be overwritten. It's a way better way to do things, and this will make it easier to game neutralize the Abomnification system. And we see here we have a zombie, whatever the hell you want to call it, with the non-uniform morphing. Beautiful. This is gonna be fun. I realize they're a little wide right here. Just going through the wall. I just exaggerated the max width just for testing purposes. That is a terrifying sight to behold. And Abomnification looks cool in a lot of different ways. You'll have to check out the streams to see it. All right, everybody. Dark Souls 1 is Abomnified. That means it's omnified. It's got all 3 of those required systems in there. Therefore, we're gonna be streaming it. And if you wanna catch the omnified action, which is gonna be pretty freaking awesome, I can't wait to play this game with it. Only place you can do that is live on my stream on Twitch, twitch.tv/omni. Of course, you can always check the playthroughs on here too when I'm done. And if you wanna stay tuned for those, if you wanna be notified, hit that subscribe button. If you like the content, if you think it's worth something, hit that subscribe button, give me a like, whatever. Thanks for your time, and I'll see you guys next time. Bye-bye.